let's start for fourth lecture. So fourth lecture, let's recall what has been done in the previous class. That is, so testing for the mean of a normal distribution. So we are doing for the case 1 where the variance sigma square is known. For that we are testing the composite hypothesis, that is mu less than equal to mu 0, and another is alternative hypothesis mu greater than mu 0. Now let's do another set of test. Let's hypothesis here, suppose that null hypothesis is the mean is greater than mu 0, or alternative hypothesis is mu is less than mu 0. And another set of hypothesis is h0 mu equal to mu 0 and h1 mu less than mu 0. So why I am writing this hypothesis? Because here you see in both hypotheses, in these two both hypotheses, the alternative hypotheses are same. These alternative hypotheses are same, and we are going to write such a test for testing this hypothesis which depends only on this alternative hypothesis. So depending on the alternative hypothesis, we gonna choose a test which will say in what is the whether we will reject the null hypothesis or we can't reject the null hypothesis within the given size alpha. So let's do it. So here it is said that mu is less than mu 0. So the test will be here, test is reject null hypothesis if root n x bar minus mu 0 by sigma 0 is less than equal to minus z alpha. So let me tell you rationale behind this choosing this test. So suppose there are two Gaussian distribution, one is this, another is suppose this. Okay. So null, suppose here there is my mu 0. Now when I will accept the alternative hypothesis or I will reject the null hypothesis, when mu we will get some evidence based on our observation that highly support this alternative hypothesis. That means its observation should lie, this is suppose another mu 1 which is less than mu 0 and this is greater than or equal to mu 0. Now suppose you get some observation here, so you see you can describe this data from both distribution. This distribution you can also describe this observed data from this distribution and also from this distribution, because the probability that how much means, that is the thing that you can describe this data set from both distribution. But what you will choose, what distribution you will choose to describe this distribution? So either you will accept the null hypothesis, that means you will say that these data points are coming from this distribution, or you can say that these data points coming from the h1, the mu less than mu 0 second hypothesis. Now you see that we will reject the null hypothesis when we will see that this data point is in the region of suppose we want to alpha, means we want to significance level alpha, then we will say we will not explain this data by the null hypothesis when this data is in the region less than alpha percentage, less than alpha probability. That means, let me restatement, that means we will reject if data belongs to the distributions below belongs to the below z alpha point. Minus z alpha point, or you can say minus z alpha point, because here I am saying why I am telling you minus z alpha point. So you see, if the probability this data point coming from this distribution is less than alpha, the probability that this data set, this data coming from this this distribution, that means that distribution which satisfy null hypothesis is alpha, is less than alpha, we will reject this hypothesis, and that means we will reject root n x bar minus mu 0 by sigma 0 if this probability of observed data is less than in this region. So what is this region? This is the z. If the probability of the cumulative probability of this side of this distribution is alpha, then remaining is 1 minus alpha. So this is z 1 minus alpha point, and we know z 1 minus alpha point. We know, since the normal distribution is a symmetric distribution, z1 minus alpha is minus z alpha. So this is minus z alpha. Root n x bar minus mu 0 sigma 0 is less than equal to minus z alpha. And you see that why I am taking this is my why I am taking such such a test, because my null hypothesis, because based on my alternative hypothesis. In the alternative hypothesis is the mu less than mu 0 and h1 mu less than mu 0. In the both cases alternative hypothesis are same, and since this data set can be explained by both these alternative hypothesis and null hypothesis, and what should I choose now? I should choose that hypothesis, rather I will say I will reject that hypothesis if that data point belongs to the alpha percentage point of that distribution. That's all. Now this is the test. Now let's going to the another. This is called one-tailed test, or you can say these two are one-sided test, because we are reject hypothesis based on the one side of the distribution. For this case, in the above side, and in this case in the lower side. So we only dealt with the one side of the distribution. So these two tests are called one-sided test these two. Now let's see a two-sided test. Two-sided test. So two-sided test is, here my null hypothesis is mu equal to mu 0 and alternative hypothesis is mu not equal to mu 0. Now you note that here mu not equal to mu 0. So how I will say that my observed data is coming from a distribution which satisfy the null hypothesis. So I have to write a test for them. So I will say my test is, we reject H0 if modulus of root n x bar minus mu 0 by sigma is greater than equal to z alpha by 2. So let's see why it is making sense. Let's see. So again, from the same logic or from the same rationale, we'll say that if my observed data is coming from the distributions, that part is below alpha percentage. So I'll say, suppose when I will reject okay, let me draw it again. So when I will reject, I'll reject if my data point is such that it belongs in this region. So my data set belong to this region which is only alpha percentage of this distribution. Then I will say that this data set, since this data set is only the alpha percentage part of the distribution, I cannot accept the null hypothesis. So that is my reason. So I will make a test in such a way that will specify that if my observed data is out of that region, is out of this 1 minus alpha percentage or the main portion, or 1 minus alpha fraction of this distribution, I will reject. So I will reject if it belong, this is less than this side. If it remain in this side, that means less than minus z by alpha 2 or greater than z by z alpha 2. So the modulus will be greater than z alpha 2, the modulus value. So if I take modulus, it will, or this means the negative x bar minus a0 by sigma should be less than equal to minus z alpha by 2 and root n x minus mu 0 by sigma is greater than z alpha by 2. So that's it. So that will be my test. Now here in these cases, whatever we discussed, that are the cases when variance is known, sigma square is known. Now suppose that we don't know the sigma square, then what we will do? Now we know what we should do, because then we have to use the sample variance, right? So case 2, 2 sigma square is unknown. Sigma square is unknown. So let's see first case. There my alternative hypothesis is mu is less than mu 0 and mu greater than mu 0, or the and another set of hypotheses for which the same test is applicable, that is mu equal to mu 0 and mu greater than mu 0. And why it is applicable? Because the tests are decided from the null hypothesis. So that's why for the these two set of hypotheses the test will be same. And what we will use here, since sigma square is not known, we will use here the sample variance s equal to 1 by n minus 1, I equal to 1 to n xi minus mu x bar minus mu, sorry, I think this is not sample variance. Sample variance is xi minus x bar x square, and x bar means 1 by n summation of I equal to 1 to n xi. And we know that if the underlying distribution is Gaussian, so here our assumption is the population from which the data are coming the assumption is the population from which the data is coming is a Gaussian distribution or normal distribution, right? So then the distribution of this test function, that root n x bar minus mu 0 by s will follow a t distribution. This will follow a t distribution with degrees of freedom n minus 1. And you see that since the standard deviation or the variance is unknown, we use the sample variance, and when we use sample variance, our degrees of freedom reduced by 1. So here our degrees of freedom reduced by 1. So we whenever we will use other than the known parameter, we have to cut off 1 degrees of freedom. So that's it. Now our test is, what is our test? Test will be as I said, test has to be based on mu greater than mu 0, the alternative hypothesis. So as you can guess, what should be my test? Here my test should be reject h naught if t, since mu greater than mu 0, this means if my t is greater than or equal to t n minus 1 alpha point, then I will say that my observed data cannot be described by the null hypothesis, or in other way around, my described data will be well explained by a distribution whose mu is greater than mu 0. That's it. So this is the thing. And another thing we can do, that one null hypothesis mu greater than mu 0 and alternative hypothesis mu less than mu 0. And here again another test, you can guess what what the hypothesis will be for which the test is same. So that is mu equal to mu 0 and h1 mu should be less than mu 0. For if mu less than mu 0, then you will say that my test will be same for this both hypothesis. Okay. Now from since you know that what my alternative hypothesis, then you can guess what should be my test. Test should be less than, right? Since if it is greater than, my test will be greater than. So if it is less than, it should be less than. And why less than? You know, if lesser than alpha percentage of point of my distribution, which has mean mu 0 or greater than mu 0, it will be well explained by the alternative hypothesis, or it cannot be explained by, or it rather the explanation from this one rather is not very good with null hypothesis. That's it. So the test will be reject H0, reject H0 if t is less than equal to minus t n minus 1 alpha. And here t distribution again, t distribution also t distribution is also a symmetric distribution. Another thing, so these two are one-sided test. Let's see both-sided test here. Both-sided test. So one is both-sided test. Both. And these tests are actually what you have seen in the many in the many situations. These tests are called the t test. So this is the t test. So we will see another this is the parametric test, because in principle we are assuming that the underlying distribution is Gaussian. So this is parametric test, and in this course we will also see the non-parametric test. So okay, let's do that both-sided test. So here hypothesis is, you can guess hypothesis what should be, add mu equal to mu 0 and alternative hypothesis is mu not equal to mu 0, and the test will be, test is reject H0 if t is greater than t n minus 1 alpha by 2, and it follows the same reason as we have discussed for this case, this Gaussian case. Same. Let me give an example. Suppose 12 items are tested and items are tested and their average lifetimes are recorded as 36%. Okay, recorded as 36.1, 40.2, 33.8, 38.5, 42, 35.8, 37, 41, 36.8, 37.2, 33, 36 in months. Now now hypothesis is to their hypothesis is that its lifetime should be greater than equal to 40. And now what is the alternative hypothesis? Alternative hypothesis is mu is less than 40. And here we will assume that these data are coming from a normal distribution. So x bar, so we don't know here the actual variance, so we'll x bar is the mean, that is if you mean it you will get 37.2833 and sample variance is 2.7319. then our test is t root n x bar minus 40 by s, so that is root 12, 37.2833 minus 40 by 2.7319, that is minus 3.4448. Now it should be if the what is the condition for rejecting null hypothesis? If this is less than, then this t, the value of t should be less than equal to t n minus 1 alpha, that is here n is what, 12, so n is 12, so n minus 1 means alpha, and suppose our significance is level is 0.05, and this is no, what I have to we have to know these things, 0.05, so that is 1.796, so is less than, that means we already know if mu is less than, then what test we should do, that t is check, t is if t is less than minus t n minus n alpha, then we will reject. So our t minus 3.4448 actually less than minus t 11 0.05, that means we reject, since it's satisfied, that means this point, this data point is in the distribution. If we want to describe this data point from our distribution where the mean is greater than mu0, we have to go beyond the region of 95%, or rather we will say that we have to go in the region where only 5% of the data, of the 5% of the total data is contained by this curve. So that's why we will reject this hypothesis, we reject the null hypothesis. So we say we reject H0 at 5% level of significance. Even at 1% we will reject this. So let's see, even in 1% we will reject. If we go means if we allow that our 5% region is included, if it is remain in the 5% region, I will include. Now I allow that if I will allow if it remain in the 1% region, then I only allow, then also I will reject. Let's see, for the 1% is lesser than this. So now let's see another thing, that we up to now we are testing the mean. Now let's test its variance. Now we'll test for variance. Test for the variance of the normal distribution. So case 1, mean mu is known, say mu 0. Our observed data is x1, x2, xn follows, we assume that it is our assumption that follows mu 0 and sigma square, and we don't know sigma square. If it is so, we will say that our xi minus mu is square by sigma square follows what? Should follow a chi-square n distribution. A chi-square n distribution. A chi-square distribution with n degrees of freedom. Now here hypothesis, let's write the hypothesis. So this is case 1, that if sigma square is less than equal to sigma 0 square, or this is my null hypothesis. My alternative hypothesis is sigma square greater than sigma 0, and on another set of hypotheses for which the alternative hypotheses are same, and as we have discussed previously that if my alternative hypotheses are same, we gonna reject, we gonna use the same test for same test for rejecting null hypothesis. And another is H0, what it should be, that sigma square equal to sigma 0, and H1 what it will be, it is sigma square greater than sigma 0. For these both two cases, these cases and these cases, we will use the same test. And what is our test? So let write first our test statistics. So test statistics, we know that test statistics, suppose W is this xi minus mu square by sigma square. This is our test statistic, and this follows a chi-square n degrees of freedom. So our test is reject H0 if W, what it should be? W if T is greater than equal to chi square n alpha point. Since it is greater than, we should, so here again this is the same logic that follows, that that if I cannot describe my data point from the 1 minus alpha percentage of distribution, will not explain my data from the rest of the alpha percentage of point of distribution, then we will reject the null hypothesis. That is our main rationale behind this test. And another thing is, this is first one. Now second kind of test is, can be H0 is sigma square greater than equal to sigma 0 square, H1 sigma is less than sigma 0, H0 is sigma square equal to sigma 0 square, H1 is sigma square less than sigma 0. That is that. For these both hypotheses, the test is reject H0 if again if this is less than, so W less than equal to chi square in 1 minus alpha point. So here you see that chi is not symmetric, so now it should be, if it is less than, it should be less than 1 minus alpha point, right? And the 1 minus alpha percentage of, means here also again the same logic is going on. With 1 minus alpha percentage of point, the chunk percentage of this most of the distribution cannot explain my data. To explain my data, I have to go beyond this 1 minus alpha percentage portion of this distribution, then I will reject my null hypothesis. So let me give an example here. Example x1 xn follows a normal 5 sigma square 10 and summation of xi minus 5 square is suppose 10, then hypothesis H0 sigma is equal to 4 or H1 is sigma square greater than 4, and W test statistics will be 10 by 4, this by this 4, that is 2.5 and chi square 5 0.505 suppose is 11.075. here suppose n equal to 5, and you see these are test statistics is less than chi square 5 0.05 percentage point, so we cannot reject. This means actually my data point is explained by the my data point remains in the inside of this region, 95% is in the 95% region of the distribution, so we cannot reject at level alpha equal to 0.05. now second case, let's see the second case, the case 2. Case 2 is this, mu is unknown. If the mu is unknown, what should we use? Let's do it. So we know that n minus 1 by s square by sigma square follows chi square n minus 1 degrees of freedom. So you see that when the mu is unknown, we have to lose a 1 degrees of freedom. Previously our test depends on chi square n. Now my test is chi square n minus 1. So I have to sacrifice 1 degrees of freedom. Now this is mu is known, then our test will be omega star is n minus 1 s square by sigma square. Oh, s square by sigma square. Now let's check for the hypothesis. So your first hypothesis, write it. Hypothesis is H0 S1 is sigma square less than equal to sigma naught square. Alternative one is sigma square greater than sigma square. So for these, and again another set of is obviously sigma square equal to sigma 0, h1 is sigma square greater than sigma naught square. For these cases my test will be reject h naught if w star is greater than chi square n minus 1 alpha, and if it is less, so if it is less, h0 greater than equal to sigma naught square, h1 sigma square greater than sigma 0 square, less than square. Another set of hypotheses, h naught is sigma square equal to sigma naught square, h1 is sigma square less than sigma naught square. So for both two cases reject if w star is less than chi square, what it will be, n minus 1 minus alpha point. That's it. Now another setup, this is all the test is one sided. Let's do a two sided test. For two sided test, so h equal to h naught, two sided test, h naught is sigma is equal to sigma naught square, and what will be h1, sigma not equal to sigma naught square. So here we will reject, the rejection region will be, or reject if w star is less than chi square n minus 1 minus alpha by 2 point, or w star is greater than chi square n minus 1 alpha by 2. So then we will reject. So let me give an example, simple example. Suppose my null hypothesis is sigma square equal to 1, and alternative hypothesis is sigma square is greater than 1. Random random sample size 25 is taken and it yields S square is 50. So n minus 1 S square by sigma square will be 24 into 50 by 1, so that is, and this is, and you see that chi square is higher than this, so we always reject the hypothesis because it is higher than, since this should be okay. Let me chi square, if you see from the table, chi square n minus 1, that is 24 comma 0.05, it should be greater than 0.05, so is greater than, is much greater than for chi square 24 0.05, so we always reject this hypothesis. Let me do another thing, that test for proportion. X belongs to binomial NP, and we have to test H0, P is P0 and H1. So why it is called proportion? Because you see, if there are some events are there and some proportion of this event is something and another is another thing, so that proportion is equal to P0 or not, because if something is happening or not, if something is there or not there, it can be mapped to the event, the head or tail. So it is a binomial kind of thing, only two possible event can possible, either it will be there or it will not be there, so that is a binomial distribution. So that's it. And if n is very large, we know that x, you know from the central limit theorem that x minus x bar by its sample mean should go towards the normal distribution with x bar and s. Now see what the mean for this binomial distribution. Mean is NP, what sigma square is NPQ. That means x minus NP by root over NPQ should follow the normal 0 1 distribution, or you can write it x by n minus P naught, here suppose it is P naught, by root over n. P naught at Q means 1 minus P naught, follows normal 0 1 distribution. So this, suppose this is P, the proportion, P the proportion, the how much of it is x, so proportion minus P0 divided by root over n, P0 1 minus P0, it follows normal 0 1 distribution. Now you see that it is a two-sided test. So when we will reject the test, suppose this is suppose another thing, suppose k. So if mod k is greater than equal to z alpha by 2, we will reject the null hypothesis. So you is it clear that why it is called test proportion? Let me repeat it again. The proportion means, suppose you do n events, and out of the n events, suppose how much proportion of it is x, or it is some kind of event. Suppose there are two kinds of events are there, suppose head and tail. So how much of it is head? What proportion is head out of the, means from my observation? From my observation, what proportion is head? Then what test you will do? That test is this: if n is large, suppose here n is large, and we assume that n is large, and large means I am saying that it is greater than 30, or greater than or equal to 30. So and our test is, if this test hypothesis test p minus p0 n minus this is greater than z alpha by 2, we reject the null hypothesis. So that's it for today. Or let me do another thing. So let me do another thing. So another test, so that I will cover today, then I will stop. So that x1 dot xn follows a exponential lambda distribution. So it's not only Gaussian, for exponential also we can test, so that exponential lambda. So my hypothesis is h0. So not only for normal distribution, you see here my distribution is exponential distribution, and using exponential distribution one can also test hypothesis. So that we will going now, that we will do now. h0 is first hypothesis, null hypothesis is h lambda is less than lambda 0, and alternative hypothesis is lambda is greater than lambda 0. Now what will be your test statistic? Our test statistic will be 2 summation of xi by lambda 0. We know this follows a chi-square 2n degrees of freedom. Now again it is very simple, that in this case okay, in this case here it is a suppose it is some kind of thing that you have to understand, that here the test is just opposite. Why it is opposite? Because you see the lambda 0 is so in the lower side, it is not the reason, but if you do the most powerful test as we have done in the previous classes, so if you see the previous classes, you will see that if lambda greater than lambda 0, then what test it will be? The test rejection region is the test is reject if lambda, if the alternative hypothesis is lambda greater than lambda 0, then the rejection will be if w is less than equal to chi-square 2n 1 minus alpha point. So here give an example. So this is the test. This is the test for rejection lambda greater than lambda 0. This one should be clear in your mind. And suppose that xi is 10, lambda 0 is 2, n equal to 5, then my test statistic will be 2 into 10 by 2, that is 10. Now chi-square 2n 10, 0.95 point is 3.94, and you see w is greater than 3.94, is 10 is greater than so that means w is greater than chi-square 10 0.95. so you see this is not satisfied, that then we cannot reject, we cannot reject null hypothesis at 5% level of significance. So that's all. So that's all for today. So thank you.